Well, hi, good morning. Thank you so much for joining me. Today is September 17th. Very, very exciting day because of this radio that's on my bench, which I'm going to talk about in just a moment. But first, I'm doing this with a new computer. I swapped computers overnight. My old computer was a Windows 10 computer, couldn't handle Windows 11. So it was one of those usual desk tower type computers, and I'll just show you the replacement computer. This is the replacement computer here, this little box. That's what's making this video right now. So if you watch lots of my videos, I'm showing you that because you might be a little interested in what's happening behind the scenes, so to speak. I've also encountered a microphone problem, so I'm just going to turn up my microphones, my usual microphones, for a moment. Bad buzz. So that's just from rearranging wires and cords, and I probably have the microphone cord running too close to a wall wart or something of that sort. Okay, enough of that stuff. What about this radio? Why am I so excited? You know, there's like 10 radios in this world that can claim to be the best radio ever built. This is one of those. This, you can call this the best radio ever built. Yeah, there's 10 others you can do that with too. They all have their idiosyncrasies and their high points and their low points. The thing about this radio is this is the second one I've owned. The first one I bought in 1977. I bought it, I drained my bank account to get it. I was a student in college at the time. I paid $350 just on what a friend I trusted told me. He said, go down to this store, they got a bunch of these radios they took down from the distant early warning line, the DEW line here in Canada. That's a radar and radio listening post located in the northern extreme of Canada. It's something that the Americans and Canadians cooperated in. We still do. Yeah, far enough away from the mainland that we can continue to cooperate with Americans, I guess. I don't know. But they would have had potentially hundreds of these radios up there. And I heard that some of them were basically tuned to one station and just left there for 10, 15 years. So this radio is an American-built radio. It came from, I believe, New York State. Could be wrong about that. Built in one factory, and they built these for at least 10 years, maybe 15 years. The other one I have, which looks exactly like this, is 10 years older than this. No, this is the older one. I think this is the older one than the other one I have. There's a few versions of these. The most common one is a JX. And I believe that's what this is. Let's take a look. So here's the name tag here, and so it's a type SP-600 JX. It says right there, and that's the serial number 2424. So this is radio number 2424. At least of the JX type. Even though this one's older than my other radio, it looks to be in better shape, frankly. So today, what I want to do with this, if I can make it all the way, may take a couple days to do this. I want to power this thing up and hear it work. Not interested in completely overhauling it at this point at all. This is months of work pretty well, and I'm not about to start it. What I really want to do is find out the general condition of it. Is it operable? Maybe we'll be operating it in here if I get bold enough. And can I just put it in my listening post and start listening with it? Over time, I become aware of its deficiencies, assuming it has deficiencies. And then I can list them out. That's what I'm doing with other similar radios. Basically, careful inspection. Get them to operate safely. Safely means nothing's overheating or anything like that. Operate them for a period of time, figure out what the deficiencies are, and then start working on the deficiencies in the individual radios back in my shop here. That's kind of my plan. At the very least, I would want to be in a position at the end of a day or two knowing what has to be done to this radio to make it work. Okay, so a quick tour of the front of the radio. This is the band change knob. Can you see? Ooh, that felt pretty crunchy. Feels like oil is needed. So you can see the pointer rising up. It's picking a different band here. And then this is the tuning knob. And the knob itself is loose on the shaft. It has kind of a bad sound to it, doesn't it? Again, it just sounds like dry gears. This is a geared radio, and if you look down inside here, you can see the gearing that's in here. If I turn the knob, you hold still, you see them turning. In here is the tuning capacitor. It's a 4-section tuning capacitor, if I remember right. So 3 tuned IF stages, and then the local oscillator is being tuned in there also. Volume, RF gain, these all feel like they have not been turned for a long. This is really sticky, really gooey. Okay, so this has an interesting feature in it called crystal phasing control. This is the bandwidth control down here. Bandwidth goes all the way from 13 kilohertz, which is a very, very wide band. These are all non-crystal circuits, and then when you flip here, you move into 3 crystal settings, and you engage this control. Yeah, I think of this as a little like a notch filter moving back and forth across the the tuned receptive area, and go all the way down to 0.2 or 200 kilohertz, and that would be obviously for Morse code and stuff like that. This also feels a little sticky. The meter's normally showing you RF gain. It's like an S meter. It is calibrated in decibels. It says decibels from 1 microvolt. So we have put 1 microvolt on the antenna, and this thing should come up, I think, to the 0 mark right here. I think that's how that would be operating. This radio also has a crystal feature. You can plug crystals in here, and then you can select them with this crystal selection control, and a little bit of a tuning left or right a little bit. Because the dial here, you cannot read a frequency directly from here. Let's get a little closer so you can see what's happening here. So for instance, I'm tuned at 23 megahertz. I can see 23 to 23 and a half is that distance. Now you can see the notches in between, but you could never be sure, and even if this thing was aligned perfectly, you'd still not be able to write down the exact frequency. So you see this other wheel turning here? So what you do is you write down the index number. So you see at the very top it says 3. So the first index number would be 3, and then 3, 4, and you can write 4, 5. Let's say the station tuned in right there. You write that down, 3, 4, 5, and what band you are on. And later you can grab this radio, tune back to 3, 4, 5, and bingo, you're back on the station with quite a bit of precision. There's quite a bit of precision on here, but the number is not frequency. And by now this has probably caught your attention. So this is an additional thing put in by who knows who. I don't know who. Receiver number 31. There's at least 31 of these guys sitting somewhere. Yeah, could be. Could easily be. I think in total, something like 60,000 of these were made, but I'm not sure. I'm not sure of that number. Okay, let's take a look at the back of this guy. What a beast. This is a hard thing to carry. I lugged it in here. It's breaking into a sweat on the way in. So lots of dust. Been sitting somewhere, that's for sure. This looks a little like a compound leak here. So this big transformer is a toroidal transformer, and you'll see underneath it has many, many, many terminals. My other radio, being the smart guy I was in college, I blew this up on my other radio. How did I do that? I thought I'd be smart, and I'd replace this big honkin' rectifier, here it is here, with a couple diodes. In the process of doing that, I blew this up. Oh, I was almost in tears. How are you ever going to get another one of these without getting another one of the whole radios? There was a store on a street in Toronto where I was living that specialized in selling junk like this. I went in and talked to the guy. I said, well, look, you know what? I don't have anything like that, but I'll keep my eyes open. Let me write your number down here. Wrote in a little book. I left. 6 months later, the guy phones me and goes, hey, you still want that transformer? I got one. I couldn't believe it. I ran down, got one of these, brought it back, stuck it in my other radio. When you look underneath here and you see the number of terminals, it's hair-raising. Wired it up, turned it on, radio back to life. That radio is still sitting. I use it every couple of weeks or so. I turn it on, maybe, about every couple of weeks. Tune around a bit with it. I have a lot of radios, so I have a lot of options for who to turn on and what to do. So he still gets play, and I still find it the nicest radio to tune. This big knob up here, we'll look at the back some more in a moment. You just can't beat this feeling. It's just, if you're a radio person, this is beautiful. Lovely radio to use. Its only downfall is you can't know exactly what signal you're tuned to, but there's easy ways to get around that. So on the output, on the back here, first thing, the power wire is wrecked here. It's no good. It's a little short and there's no plug on it. Somebody cut this off. And you say, why? Why did you cut this off? Well, there's a good chance it's cut off because there's something seriously wrong in the radio. And the guy cut it off to make sure nobody plugged this thing in again. That's possible. Another one is he cut it off because it was just in the way. Well, he's moving this thing around or storing it, cut that wire off. Or he noticed the wire was wrecked and thought, wow, I don't want anybody plugging this in, so he cut it off. He didn't cut it flush. Who knows? There's all these possibilities, but there's a reason why this got cut, and we don't know exactly what the reason is. The antenna goes in here. This is an IF output. Pretty sure. What does it say there? Let's just be absolutely sure. I am quite familiar with this this radio. There we go. IF output. So you can, a very interesting thing to do with an IF output is to feed this right into an SDR, tune the SDR to the IF frequency, which I think in this radio is 455. This has two it's a double conversion receiver, which I'll talk about in a minute, but you can tap out the signal here, stick it in your SDR, and see some real interesting stuff of what's going on kind of right in the middle or inside this radio by looking at it. The audio output here, so you can connect here and phono. So this says phono, and you might think it means phonograph, but it really doesn't mean phonograph. Nobody's hooking up a record player to this. This is a signal level indication. I believe. I think this is an output. So, for instance, in my other radio, it has another output on the back called diode output, and that's where I steal the audio from the radio. I don't bother having it go through the audio circuits. So I'm able to pull out a couple of tubes also from my other radio that just isn't required because I'm not using the audio amplifier. I'm stealing the audio signal out a little early, but I can't do it with this one. Don't know exactly where this is connected. This might also be connected kind of ahead of the audio circuits, just after the detector. These are probably meter adjust. Come on, flashlight, you can do it. You got something in you. Huh. That says BFO, so that's a BFO adjustment. This says adjust RF meter. RF meter level adjusts. And then this one here, meter audio adjust. So the front meter can read either the RF signal like you would expect, but it can throw a switch on the front panel and it'll show you the audio level. And so this adjusts the audio and that adjusts the RF on the meter on the front. Okay, this says relay. So I'm guessing if you're using a transmitter and you want to cut this radio off when you transmit, you would energize this. But I'm probably wrong. I'm not sure of that. And this is just an additional outlet here. Now he's got 3 amps and a half amp, but I thought this was a spare fuse. They don't look the same. The holders are different. Don't know the story there. Maybe there is a story. Okay, so just looking over the top of the radio now, and I'm looking for anything that stands out. I see all these holes are capped. On my radio, these are all open. The caps are all missing, and it's because of me. Down here are some adjustments and some wires that are soldered down under here that are of significance. Obviously not going to look at them. Here's all the tubes. The tubes aren't in place. There's a note. What's he got here? I don't know what the first word is. 7.4 megacycles only. So this is probably, I mentioned the radio is a dual conversion radio. This is probably for the higher frequency. Okay, from here, I think we gotta look underneath it from here. So I'm just gonna take a little break here, make sure my video is working, and because I'm using this new computer, everything's new, and we'll carry on after that. Okay, time to look underneath. What we're going to find out now is, has anybody else done work on this guy? Baby, she's a heavy one, all right. There we go. Whew. Okay. There it is. So looking at a distance here, what do I see? I see an all original radio here, I believe. Nothing has been done underneath here. So what gives me that impression is a few things. Original capacitor here. I still have the original one in my radio. These molded capacitors that you see down here, that's interesting. My radio, this is I figured this out to be the older radio by 10 years. My radio originally had wax capacitors all through it. But this one has molded capacitors. They seem to come a little later in the game, I think. The molded capacitor was an attempt at improving wax paper capacitors by housing them in a plastic shell. But inside, I believe, is pretty much the same thing as a wax capacitor. Nobody's done anything. Uh-oh. So my other radio suffered a number of capacitor failures, open circuit and short circuit. Most of it happening in the IF strip, which is up on top of the radio. It's not down under here. Well, wow. Do we dare turn this thing on? Now my experience with radios like this is, even though they might be really old, the components were generally of high quality. I'm not suggesting for a minute this is a high quality component, but I've had great success with just turning them on. What could go wrong? Well, there is a very serious problem in these radios, if I remember right. which, if the problem exists, I think it's a shorted capacitor, I'm not sure now. And you turn on your radio and it doesn't work, and so you try the different bands. Every time you flip a band, you burn another capacitor out. There's something like that. I'm pretty sure it was this radio. Haven't experienced that, and I don't know if that's really a valid concern. Maybe it's a false memory on my part. Well, what do you think, Bert? What do you think? Should we plug this guy in and turn him on? Put a new power cord on, and I can bring the power up slowly. What are the chances that something like this is going to work? To me, surprisingly good, but still maybe pretty low. I'm just looking everything over in case you're wondering what I'm doing. I don't see anything here that really jumps out as clearly a problem. Just the cat. What are you doing there, Bert? Oh, he loves these sticks. Give me a stick to chew on there. That's the pointed end. Use the other end. Here, take this out of your mouth. We'll use this end. There you go. Okay, I'm going to drink a little coffee and think about this a little bit, and maybe we're going to try starting this guy up. If I were to do some things before starting it up, they would be a long list of things that would be done. So it's either take a little gamble here, start it up as it is, or spend a lot of time. My own philosophy about this is, what you're really trying to do is get the radio working to any degree as quickly as possible with as little work and effort as possible. Once the radio is working, from then on, it's kind of a safer process to continue working on it. So what I'm trying to say is, let's say I decide I'm not going to turn this thing on until I change all these capacitors. So I change all these capacitors, I turn it on, and it doesn't work. Now, what happened? Did I make a mistake? Is there some other problem? And it goes downhill from there. So that's the only reason why I would want to try to get this thing working before I do anything to it. Because once it's working, I can recognize my subsequent errors as I'm working my way through it. I guess that's the best way of saying it. Okay, Bert. He's always lost his stick. Stick to the ground, Bert. Okay, break time here. Okay, so I have with me a manual, a photocopy of a manual. This photocopy was made 1977 or so, that I got with the other SP-600. So let's just take a look through it. There's, kind of remind myself what I've got in here. This is the schematic. I'll can fold this out. What do we got here? Some other information. Loose pages. Notes. Tube socket voltages, table number 1. This is what I'm looking for. So this is obviously from my other radio. Tube socket voltages, and this one, tube socket resistances, right in the front of the book here. And this page, this very confusing page, which came out of the manual. Bert, you're not being very helpful here. This is historical documents, Bert. Come on. So this one's showing the different tubes and the different voltages and resistances here. This is, resistances. So the way you would do this is with the radio off, you can measure these resistances. And the idea is you can do it from the top. You don't have to turn the radio up like this. You pull the tube out, measure down through the pins, and you get these readings. And this is really helpful at finding trouble in the radio. So I'm likely to utilize it. Look at the notes I made on here. I have no recollection of doing this. This might not have been that long ago. Check settings, shorted bypass, 3/4 open resistor, cold joint. Ah, good work. Don't remember doing any of it. Let's look through the manual here. Ay, 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 ay. Come on, don't claw me like that. No claws, cat. There we go. Okay. Introduction. Purpose. The purpose of the radio. Just read this little paragraph here. Radio set SCR244D, figure 1. This is figure 2. Figure 1. SCR244D. So the different services in the United States, it would name the same radio with different names, different numbers. Oh my gosh, I'm not going to get anywhere here. My God. Bert, come on. This is just a book. Not that much fun. So, but that certainly looks like the radio. They all look like this, pretty much. A little bit of differences here and there. Is a general purpose radio communications receiving set. It is intended for fixed field station use. Radio receivers are 483 FRR, 483A FRR, either of which is included with radio set SCR 240. See why this is confusing? Starting to figure out, well, what radio have I got? And radio receivers R320A FRC and 274A FRR. I don't know what all this is. Each receiver. Okay, are we still on? My cat just walked across my keyboard. We're still there. I think so. Still recording. I think so. Each receiver provides continuous tuning for selective reception of radio signals within the range of 540 kilohertz to 54 megahertz. Radio receivers, blah, 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 have added provision for fixed frequency crystal controlled reception of any signal within this range. It's actually limited. Amplitude modulated, CW, frequency shift radio signals may be received. Voice and CW are made intelligible through the use of an associated headset or loudspeaker. Automatic high-speed Morse code made intelligible through the use of tape, ink, recorder, and auxiliary equipment. Teletypewriter signals are made intelligible through the use of a teletypewriter and auxiliary equipment. That's kind of the high-level overview. System application. Each receiver may be used in diversity receiving. Diversity means you have maybe two antennas, and you switch between them depending upon which one's working better, or more typically you have two antennas, two receivers, and you switch between them based on who's receiving the signal stronger. So you can pick up a signal, maybe two different antennas, and then mix them together to get one result coming out of your speaker and get better reception that way. Each receiver may be used in diversity receiving systems. The receivers may be in close proximity to each other and other station equipment. Space diversity receiving systems provide distinct improvements in the reception of high frequency radio signals. They are used to overcome severe signal fading and to maintain receiver signal to noise ratio. It goes on and on. Okay. Following a list. This is what comes in when you get the radio delivered. This is what's in the box. General description. Yikes! I'm not going to read that. There's the front. There's the back. Now, this is where you can start trying to decide which radio you've got here. Now, mine looks exactly like this. There's the outlet. There's the relay jack. There's the phono. There's the IF. Exactly like this. Radio receiver 483 FRR. But again, that's the numbering system used by, what is this? Is this for the Air Force? Who's this for? I'm not sure now. Different pictures of the radio. Different versions. This is the version I have. The other version I have has this diode output on it. 320A. But the differences are not so much the internal circuitry as some additional features and things like that. So basically all these radios are the same. Differences between radio receivers. So I've studied this to try to figure out which radio I've got. I'll be doing that again, but not on the video. This is kind of interesting. Sighting. You got to picture yourself. You know, you're in a war and you got this radio and you got to listen to the enemy. So what are you going to do? So it shows you good location. It's in the countryside. There's a shack. Can you see the shack? And then there's the antenna up on a tower. You can even see the antenna drop lead into the shack. Good. Bad. You're right near these power lines. That's basic. And what's this car out front for? These guys are chit-chatting. Why is that bad? Look, look at this. I didn't notice this before. That's a horse-drawn cart here. That's a vehicle. This is bad because you've set it up near the Golden Gate Bridge. Why would you? This whole same shack, same shack. Well, now you're at the Golden Gate Bridge. That's bad. There you can kind of see the antenna up above. There's an insulator and a wire and an insulator there, and probably the drop wires right there going into the shack. Bad, bad, good. Good. Hilltop, flat terrain, or near large water surface. Bad. Near high tension wires, steel bridges, or in valleys or depressions. Oh yeah, it says a valley here. What about these guys talking though? He didn't comment on that. Service upon receipt. Layout diagrams. Again, there's multiple radios, so there's multiple diagrams. Here you are. Here's an interesting one here. They're showing the antenna here. This is a stocked item. Of course, everything in the Army is a stocked item. So they're giving the stock numbers. W152, spacer, insulator, IN124. Got to order me one of those. Look, they're showing a support rope. Connect the headset. Navy type. So this is the Navy manual. Navy type number 49507 by its plug PL54 to jack JK26. A bunch more diagrams here. Operation under unusual conditions. What's the unusual condition? Starting procedure, selection of crystals. Reception of voice, reception of CW or phase, frequency shift. Operation under, this must be usual conditions. Unusual conditions. Any one of the receiver types may be required to provide for reception in regions where extreme cold, heat, humidity, and moisture, sand conditions, etc. prevail. In the following paragraphs, instructions are given on procedures for minimizing the effect of these unusual operating conditions. Operating in Arctic climates. I'm not going to read through this. I mean, if you're really interested, I'm sure you can find this on the internet and that. But it just, you know what? When the radio receiver is inside a heated enclosure, located so there is no danger of a cold draft striking the vacuum tubes through the side, top, or rear vents. Operating in tropical climates. When operating in tropical climates, radio equipment may be installed in tents, huts, or when necessary, in underground dugouts. When equipment is installed below ground, and when it is set up in a swampy area, moisture conditions are more acute than normal in the tropics. Ventilation is usually very poor, and high relative humidity causes condensation of moisture on the equipment whenever the temperature of the equipment becomes lower than the ambient air. To minimize this condition, place a lighted electric bulb under the equipment. Isn't that, you know, that's not much of a secret. Once you turn the light on, it's not, you're not operating. Operation in desert climates. Never tie power cords, signal cords, or other wiring connections to either the inside or the outside of tents. Desert areas are subject to sudden wind squalls which may jerk the connections loose and break the lines. So be prepared for your tent to blow away while you're huddled with your radio, you know. You're going to get caught. Organizational tools, preventative maintenance, lots of charts. Special tool here for working inside the radio. That tool's probably got a number. What's this chart? This is an interesting operator first echelon maintenance checklist for signal core equipment, radio communications, direction finding, carrier, and radar. Kind of a standard sheet there. Lots of instructions. Troubleshooting at organizational maintenance level, lubrication, weatherproofing, system sectionalization of trouble to a component, troubleshooting by using equipment. This is actually a very well written manual. And the specifics to working on this radio, it can be generalized. This is kind of a general instruction for working on all radios. Equipment performance checklist. That's something I might want to go through if I really want to be that serious about it. Look at all these different things here. For instance, modulation CW switch. Set at CW position and tune in a CW signal on one of the HF bands. Be sure that the beat oscillator control is set to 0. Normal indications. Beat frequency audio signal is 0 beat when receiver is tuned. Corrective measure. Replace tubes V12 and V13 in turn. Really? Wouldn't you, like, if this is not 0 beating, don't you want to make an adjustment? You start changing tubes? Theory, this is great. I'm certainly not going to read it to you, but here's the block diagram for the whole radio here. To understand all of its little bits and pieces on a block diagram basis, and then here's a detailed description. You need some engineering background to read that. More diagrams here. Again, multiple diagrams because there's multiple versions with small variations in it. The second RF amp, just more explanation, more explanation, more explanation, more explanation. Still explaining this radio. Lots of explaining going on. Like, for instance, detector, vacuum tube 14A. Detector V14A functions to extract the original intelligence from the signal carrier tuned in. It is a diode type that provides a minimum of distortion that actually decreases with an increase in input signal level. The DC loading of V14A is in series with a combination of resistors R63, 64, 65, potentiometer, blah, 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 blah. Also, when the AVC manual switch S8 is in the AVC position, the resistance of meter M1 in parallel with R69 and R102, figure 40 only, is part of the DC load. You get an idea how much, you know, you really, read a paragraph, spend an hour understanding it. Yeah, read it in a minute and spend an hour understanding it. Noise limiter. Look at this. This is detailed descriptions of how everything works. Here's my own personal notes here from my other radio. Don't know if that's a field maintenance instructions. So what if you're in that hole? You've dug a hole and this radio's in the hole with you. I don't know how you're powering it. How are you powering this radio? Not by batteries. Troubleshooting data, general precautions. Oh, you better read this. General precautions. Whenever the radio receiver is serviced, observe the following precautions very carefully. A. Wear goggles to protect the eyes from dust when using compressed, dry, filtered air to blow out the receiver. B. Choose the power transformer primary tap that has a voltage rating closest in agreement with the AC voltage source. C. Maintain the proper fuse to prevent damage. D. In an emergency, turn off the receiver by pulling the receiver power cord plug from the AC power source. Yeah, don't just run away when your radio catches fire. When the receiver power has been turned on, do not switch it off and on again. This may cause that looks like a 3/5 ampere pigtail or cartridge type fuse, as applicable, to blow because of the excessive initial filter capacitance discharging current. In power systems, forgetting this radio for a minute and talking about electric power systems that provide power to a city. So you have these heavy cables that are running under the streets, and these cables have a rating. The rating is based on their temperature, by the way. There is no current rating. It's really a temperature rating, but because back in the day nobody had a thermometer to run around and measure, it's much easier to measure the current. But the issue really is how hot is the cable getting, or how hot is the radio getting, or how hot is anything electrical getting. It's not how much current. So we have this cable running, and they run hot, hot enough that they're uncomfortable to touch. So we go down in a manhole under the street. There's these big cables in there. You put your hand on it. Whoo, hot stuff. Now, what happens if that cable has a fault? So somewhere down the way, some guy with a backhoe digs into the cable and shorts it right out. So for 4 or 5, or in the system I worked on, 4 or 5 or 6 cycles of energy will flow down to the fault, through the fault, and then back to the station, because there's a short circuit, because one of the guy's shovel teeth is right in the cable. 4 or 5 cycles. That's a fraction of a second. The temperature of the conductor will jump upwards because of the huge current flowing. It will jump upwards. This will cause the cable to instantly expand. I'm only talking about a millimeter or two over 100 meters, but it's a shocking expansion like that. Now the breaker opens in the station, and the current is cut off, and the cable's just laying there. But now it's extra hot. So what if you close the breaker and engage the fault again? Because that's a procedure that can be done. Close the breaker, fault goes again. The guy on the tractor's pants are full by this point, by the way. Boom, another 4 or 5 cycles, that's all. Now the cable is so hot it is getting damaged because it has jumped up again in temperature. Same thing with the fuse here. When you first turn the radio on, the rush current comes in, the fuse warms up. But then the normal current actually will let the fuse cool off and go back. Turn the set on again, rush current up again. I don't know why I'm holding my hands like that. A fuse looks more like this. The fuse goes up in temperature. Now if you repeatedly cycle that on and off, up and up and up until it finally gives out, because that's what fuses are designed to do. I thought the power cable example of this phenomenon was interesting. Cables are rated that way, so you can allow one fault, and that's it. If there's been a fault on it, you can't operate the cable till it cools off again. This wasn't paid close attention to by the way in the company I worked in. If a cable's running at 30% of its capacity, then these issues aren't significant. But it's when you've got the cable loaded up to 80-90% of its capacity, which means you're really working the copper. You're getting value out of all the copper that you've got under the streets to carry current. So electric systems tend to run towards the upper limit of their heat. They tend to have consumed their heat capacity, if you like. They're running as hot as you dare. So one fault, can't take any more. Oh, I'm having fun talking, so let's carry on here going through this book. Checking bias and B+ circuits for shorts. Let's read this because this is exactly what I'm intending on doing. Trouble within the receiver may often be detected by checking the resistance of the bias and high voltage circuits before applying power to the receiver. Make the following chart checks before attempting to put the receiver into operation. Doing so also prevents the needless overloading and blowing of the receiver's self-contained power supply fuse F1 or F2. All readings are between the points indicated in chassis ground. Remove V19. Pins 2 and 8 of V19. Normal resistance 46 ohms, 15.8K. That's a 46K and 15.8K. In radio receiver, here we go again because you got multiple receivers. From serial number 487. Oh my gosh. to a large degree, when you're making these measurements, it's almost a go, no-go thing. If I'm going to get out the ohm meter and look for 46,000 ohms, and I'm going to find 44,000, am I going to jump up and down? No. If I find a 0, yes. If I find infinity, oh yes, be jumping up and down. But a little variation from these. This old radio, everything is off a little bit in it. So this chart is what I need to go through. Wait a minute. These are the charts here. What's this other stuff? Troubleshooting chart. Oh, this is just your stuff like, if receiver fails to operate but dial lights light up, then do these things. Here's the confusing set of charts here that show the resistances for the different versions of the same radio, and I got to figure out which one of these is mine. Like, not my radio. Not my radio, only I crossed out not, just showing how confused I am. This is my radio. I wrote up here. Yeah, and I don't think I got it right, to be honest with you. You know what? When I first received this radio here, I was curious about, well, how does it compare to my other one? And I used AI to help me sort through the two radios, identifying features and things like that, to identify, what vintage of radio each one was. And of course, I've forgotten all that now. So I think we're getting towards the end here. This is here's some diagrams showing you different things in case you need to find them. Tubes and transformers, different radios. It's like 3 or 4 different radios here. What's this in here? Some kind of additional circuit or something. Why is this in the back here? Radio receiver, all types other than R274, from serial number 487 through to 1569, B plus voltage distribution. So, again, to me, it's more a question of go, no go than precise. DC resistance of transformers and coils. Hello, Bert. Troubleshooting RF strip. So in this radio, I'm going to show you this. This is one of the challenges of this radio. I got to flip this down now. I should turn the camera off at this point. Look at all this. What's all that? Something has leaked out of somewhere and collected. There was a bottom panel on here. You can see the screw mounts for it. Collected on the bottom panel. Where did it come from? Ooh, it may have come out of the main Look at the main cat. No, it didn't come out of this part of the cat. No. In here. Wow. So you can bet that this transformer is potted. It has compound in it. It's completely sealed. The can is soldered sealed. How could it leak? Well, I guess where each one of these terminals goes through, there's some kind of insulator, and there you can start to see the number of terminals that are on this thing. Well, that's not good. If all the compound had leaked out completely, I think the problem there is heating, too much heating. Bert, stop looking so cute, would you? Oh my God, all day long this goes on with this cat. There's a wire tie here that's been cut. Great. I don't think that's of any significance at all. I don't see anything in here at all that makes me think, wow, this is in bad shape. Quite the opposite. Okay. Let's put this down. Okay, hold it. Don't go anywhere. Okay. Hold still. Everybody hold still. Nobody move. Wow, this thing is hanging here. too much for Bert. He's leaving. Okay. This guy up here. Right, I was going to show you the IF strip here. And the problem, one of the problems with this radio. So the antenna connection is here. This is the IF strip right here. This is it. First IF amplifier tube, second IF amplifier, third IF amplifier, oscillator tube. That's what's on here. Underneath here are components, of course, tied to the sockets that are down below here. There's only way to access this is to remove it. To remove this top panel, you remove this cap here. This is just a strip like this. You take these off, take this cap off here, desolder 6 or 7 wires in here that go into the IF strip, and then you lift this out. Now what's the problem? Well, the radio's apart, so you can't do anything in terms of testing. So once you take it out, well, okay, let's change some capacitors. I mean, if I were to take this out, I would do a full maintenance thing on it, refresh all the capacitors, check all the resistors, do all that kind of stuff. But did you make a mistake? I don't know. You got to put it back in. That's a big operation, putting it back in, soldering all these wires, getting it all right, and then finding out, ooh, it didn't work. Why didn't it work? Well, gee, I don't know. Can you test it? You can't really test it. It's back in the radio now. So you got to take it out. How they handled this at the Hammarlund factory, they probably had a test jig or something like that to solve this. But this is a bit of a problem with this radio. Otherwise, this is an easy radio to work on. Everything's quite exposed underneath, but not the IF strip. And almost certainly, it's going to have to come out of this radio at some point. These little caps here, you pop these caps off. You know, long alignment tool. You slide it down on an angle about like this. You go way down and engage with adjusting screws that are mounted on the turret. There's a big turret inside here, right? When you turn the band change, there's a big thing rotating inside here, which we will see at some point. And it's rotating all of its adjustments. So you rotate to a new band, a new set of adjustments shows up at the bottom of these I don't want to call them channels. They're not. You have to be very careful and get the screwdriver down into the proper spot to make the adjustment. It's quite a hairy deal. All good things to look forward to. That's why I have no intention of just working away on this radio from start to finish, because it will be in here for 6 months. My plan again is to get it into an operable state where it can be operated safely. It doesn't have to be working well. Just I can turn it on and nothing's gonna, you know, burn up. Especially this guy, especially that guy. So, what to do today? What more could we do today? A lot of tubes in here to test, but I'm not about to do that. I drink some coffee. I think that might be the best thing to do. I am not going to rush at this project. I really do want this thing to be working, and it has the potential to destroy itself, as I discovered way back in college when I destroyed one of these. Think you're going to get another one of these today? Good luck. Okay, coffee time. Okay, I think I'm going to stop here. What I'm going to do is today I will identify positively which version this radio is once again, and then tomorrow I will go through the socket resistance tests, looking for anything that's way out of sorts, and part of that is preparation for turning on the radio. If I find something, well, there we go. If I find something up in here, my other radio, I'm going to show you a picture of it in a second. Had a series of capacitor failures up in here, because I didn't go through and change all the capacitors. I just kept operating the radio when I first got it, and after a few years, pop, pop. So I took this out a number of times to deal with it, and I found the fault by doing this resistance check. So it's really quite valuable. Here's a look at my listening post, or part of it anyway, and you can see the SP-600 sitting there. On top of it is an R390A and some other radios here and there. An interesting thing is this piece here. This is an HC10. It's a Hammarlund HC10. What a little bit of pointer craziness going on here. Yeah, this thing here. This is what I'm talking about. This guy will pick up the IF signal from this radio. There's a cable that runs between here, the IF output here, and the IF input here. And then this is its own radio from then on. So this is a really high quality piece of equipment. That's the best way I can put it. I don't know how many of these things are floating around, but so you can take any radio, extract its IF signal, stick it in here, and end up with a much better result than you would out of the radio to begin with. That's what that is. Okay, well, thanks a lot for watching today. Tomorrow, as I said, I will try to do those resistance tests and look for something grossly wrong with the radio. And then we'll consider firing it up. Thanks a lot for watching today. We'll see you.